Alrighty, so we're into our 128th installment here, and I'm just going to make a couple little notes before we get too far into this one with you. We're talking about section 2.2 of chapter 2 now, and we're talking about constructing parallel lines. Now, this is all about what we call geometric constructions, and if you have a teacher who's a little bit even older than I am, I'm not going to say how old that is, they probably remember that when they were in school, they used to have to do geometric constructions. Now, if you have a teacher who's younger, they might not remember doing that. But it was a long time ago done that there was this whole topic in geometry where students would be given a ruler and a protractor, or sorry, a ruler and a compass typically, and that was it. And you were told or shown procedures for constructing or for being able to draw certain properties. So with just a ruler and a compass, you had to be able to draw two parallel lines, or you had to be able to draw an angle bisector, or all kinds of different things that would have to be able to construct. And this is a bit in this course. This is still a fairly new course now. It depends on how long it is in the future that you're watching this video, but this is sort of a bit of a revival of geometric construction here. So what we're doing is we're kind of bringing back a little bit that old geometric construction, but the only construction that we have to do is constructing parallel lines, okay? But we have to be able to do it two ways. We have to be able to construct parallel lines with a protractor and a ruler, or just your protractor, which also has a straight edge, and with a compass and a straight edge, okay? So there's not going to be any practice questions for this stuff, because basically it's just two procedures you have to follow, and it's the same thing every time. So let's see how this goes. It says, following the given diagram, construct, so what we're doing here, first of all, is we're constructing parallel lines with a protractor and a ruler, okay? So the first thing we would do is we construct this line AB that goes from here to here, okay? So that's our first step. This is the easier of the two ways, by the way. The second thing we have to do is we have to construct a line PQ, okay? So basically all you do is just draw another line that intersects the first one. And it doesn't matter what angle they intersect at or anything like that. You just draw two lines that intersect. So the first line is AB and the second one is PQ, and you have to intersect at, well, you can call them anything you want, but just for consistency so that we can all follow along, we'll say Q is the point where they intersect, okay? So that's the first part of this is real easy. Just draw two lines that run into each other and label them up like that, okay? Now, what you do first is you measure PQB. Now remember, the letter in the middle is the one that's actually at the angle. So angle PQB would be this angle right here. So the first thing you do is you measure that with your protractor. Okay, whatever angle, 45, 90 would probably be one of those. It might be something like 53 degrees or something. Okay, so whatever that measures out to be, then you just take your protractor up to point P up here, and you have to measure out that same angle. Okay? And when you do that, you just construct a similar angle up here, and then by drawing a line along the straight edge there on that same angle, what you end up with is a pair of parallel lines. Now, why does that work? Well, if you'll notice what we've done here is we've made use of one of the properties that we had for parallel line transversals. We've made use of that transversal to show you that these two angles that I've sketched here are actually corresponding angles. And we're just using the fact that corresponding angles being equal guarantees us that the lines are parallel. And we just make that property work for us, and that's what allows us to construct those parallel lines. Okay, this one is more complicated. We're going to construct parallel lines with a compass. Okay, so no protractor. We can't measure anything, basically. So the first thing we do is we construct PQ with a straight edge. So that's this line here. Construct that and label a P and a Q. And then construct R. So just put a random point floating above it up there somewhere. Next step, we're going to construct a line from R. This is very similar to what we did before, down to J that intersects PQ. So now all we have is just two intersecting lines and we've labeled them up. Okay? So from there what we do is we take a compass. All right. And with our compass, you sort of anchor it down here at J and swipe out any arc that connects RJ, or JR, whatever you want to call it, and PQ. That's what we've got done so far. The important thing is keep your compass setting. So don't readjust your compass, leave it set the same way. Then you take your compass and you anchor it up here at R, and you draw out another arc above the other one. So we end up with these two arcs. So one anchored at J and one anchored at R. So they should have the same radius, okay? But we have these two arcs drawn, okay? From there, what we'd have to do is we have to reset the compass now for the first time. So we reset our compass to measure a distance from this point where our first arc intersects JR down to this point where it intersects PQ. Okay, and once we have that distance, then we're going to take our compass and we're going to anchor it up at this point, okay, where the second arc meets JR. And we're going to use that to sketch this little arc down here. And where that little arc goes through, we're going to call that S. Okay? Now, we have all that funny business done, but if you now connect the points R and S, thusly, you will have a line that's parallel to your original PQ. So RS is parallel to PQ. And really what we've done is we've made use of the same property. By resetting our compass to be the same distance here to here as it is from here to here with the same sort of arc on it, which we already measured that these guys were the same distance, J to this point and R to that point, then we've made these two angles the same. So we've used corresponding angles again. And that's the same thing we were looking at before. As long as we keep those properties consistent using corresponding angles, what we've actually done is we've constructed parallel lines. Geometric constructions. A bit of a blast from the past, but it really helps us with understanding our corresponding angles. So making use of the properties of angles in parallel line transversals, we can make geometric constructions of parallel lines. So parallel lines constructed with a protractor or with a compass and a straight edge. Okay, there is a third, although less accurate method for doing this, and you can use paper folding, but the paper folding method doesn't really make use of our properties, so I'm not really keen on it. Your teacher might like that, but if they do, you'll go over that in class. All right, good luck.